The goal is that we want to better understand the processes, to want to better model the impact of planned actions and planned changes to our environment before they are actually carried out. Everybody knows 3D city models. So basically, if you open up Google Earth, if you zoom in to the street level, you can see all the environment in 3D. The Semantic 3D city models, they add another, you could say, fundamental dimension to it. Because in semantic city models, every object knows what they are. So for example, for the buildings, we know that these polygons all belong to one specific building. We know, for example, the building addresses, at what age was this building being constructed, what is the energy consumption of the building, and all this kind of thematic information is then linked with the building objects. But of course we are not just looking at buildings, but the same we are doing for trees, we're doing that for streets, for tunnels, for bridges, also for power lines. They are all represented, so in a sense that you have something like a digital twin. And because you have this information about what types of objects you have, you can of course also add information, specific information, for example, concerning energy. And you can think about, for example, noise that is being emitted onto the walls of a building by cars, by factories, by trains. And you can then combine all these kind of diverse information on the city in the city model, and so it can become an information hub. And the goal is that we want to better understand the processes, to want to better model the impact of planned actions and planned changes to our environment before they are actually carried out. And the idea is to use these virtual models to run simulations. That could be environmental simulations, that could be mobility-related simulations, that could be vulnerability simulations, but also energetic simulations. For architecture, for example, the city models give geographic context. So it means if an architect is going to plan something new, of course he always has to consider not just the building itself standing alone, but of course it has to be integrated in an environment. If you think about building a high-rise building directly in an area which is important to provide fresh air to another city district, you probably don't want to have a high-rise building which stops this fresh air flow into the city. So that means you can also use these kind of models then to validate and see what is the impact of the design on the rest of the environment. We took the chance to have a joint PhD student seminar, and so I was invited and also supported here by TU Delft to bring the entire group. We were invited by Rotterdam and The Hague to see what their current work is, and I was really impressed about it. They also realized that it is not sufficient to have just a snapshot, but of course the city is constantly changing. One direction forward and one kind of development that we are doing also at TU Munich is we are investigating how can we represent the evolution of a city over time, and that means when a building is being erected or some building is being abolished, or there is a construction site also on the road blockings, for example, which are also constantly changing. There's another aspect on time, I call them the fast changes of cities, and that is basically if you have buildings which are equipped with sensors, smart meters, which are measuring the resource consumption like electricity or water. You have temperature reading sensors, you have air quality sensors, and of course they always are located. And so what we do is we link that, and by linking it, we give a meaning to the stream of data that is coming from the sensor. We're not the only one in the field who are working on 3D modeling. The colleagues from civil engineering and of course also from architecture, where they are currently bringing forward a concept that is called building information modeling, BIM. The idea of BIM is that you plan a completely digital model before you construct anything. But these kind of models are being driven mostly by people who are designing and creating buildings. What we are doing is we are trying mostly to represent our environment from what we can observe. So as built, you could say, everything that is already there. And these kind of fields, they are approaching each other and getting together. What I really liked about this visit is really that we had further identified the strong bonds that we have between the two research groups here at TU Delft and at TU Munich. And there is a high and a strong coherence of the topics and the research questions that are driving us. And that makes, I think, this kind of collaboration really fruitful and has a high potential to become even stronger and more extended in the future.